Alright, Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to start with a new chapter, which is estimation, chapter number 3. Right. So the learning objective for this chapter is to describe the point estimation, which is especially for mean, variance, and proportion lah. We're going to focus on these three estimator, which is mean, variance, and proportion. So another one is we also want to identify the method to get an estimator, right? So there are a lot of method to get the estimator, which is method of moment, method of maximum likelihood estimator, and we're going to define good properties of point estimation, which is unbiased estimation, sufficient, minimum variance, and efficiency. Right, and then for chapter number 4, we're going to find interval estimation, which is a confidence interval. So the learning outcome, right, after completing this chapter, you should be able to describe the point estimation, identify the method to get estimation, define the good properties of point estimation, and last is to find the interval estimation. Right. So now let's look at the introduction. Estimation is numerical values assigned to a population, right? So it's a numerical value assigned to the population parameter, such as mean, variance, sigma squared, and so on. And by using a sample statistic. So you need to remember, to get an estimation or estimator, we need to use a sample statistics, such as X bar, as S square or S or P proportion, right? This the procedure of estimating, first one, we need to select a sample and then collect the required information from a member of the sample, calculate the value of sample statistics such as X bar, S or S squared, and P, right? And then we're going to assign the values of the sample statistic with a corresponding parameter. So let's say mu hat should be equal to X bar. So this is mu hat is your point estimator. This is what we call as point estimator, and this is what we call as point estimate, right? So means the value corresponding to the X bar is what you call as a point estimate lah. Right, the point estimator is the value, the symbol for point parameters. Right, a statistic is used to estimate. Just to make you clear, statistic means that a numerical summary taken from sample, right? So if you forgot about the definition of statistic, statistic is a numerical measure taken from sample or calculated from sample. So statistic is used to estimate the value of parameter we call as estimator lah, right? So the estimator of mean is denoted as mu hat. Mean, for this is a parameter mean, we denote as mu hat. So the estimator for standard deviation is denoted as sigma hat. So this is the symbol for estimator. So every time you see the symbol of hat atas daripada simbol estimate parameter tu, so this is what we call as estimator lah. You see ada hat, right? So hat represent estimator. So now there are two type of estimation that we're going to learn in this subject, which is estimation from point estimation, and another one is interval estimation. This is like current chapter 3, and this is going to be on chapter 4, right? So we're going to learn two type of estimation, interval estimation and point estimation. So let's look at what is a point estimator or point estimation. It based on the sample data, and we're going to have a single number to be calculated to estimate the point, the population parameter, right? So we're going to have only a single value. Let's say mu hat should be equal to x bar, should be equal to 2.38. So we're going to have only single value, right? So the rule of formula that describe this calculation we call as a point estimator lah, right? And then the resulting number we call as point estimates. For example, tadi I ulang sekali lagi. This is what we call as point estimator, and this is what we call as point estimate, right? So this is the definition for point estimator and point estimate lah. So now we'll look at interval estimation. So the definition of interval estimation is based on the sample data. So you need to remember, when we want to do estimation, it based on the statistic sample data, right? We have two numbers here to be calculated within to form an interval which within the parameter is expected to lies lah. Means that, let's say we have mu hat should be, we're going to have a lower confidence limit and another one is upper confidence limit. So they're going to have two value, right? So the rule of formula that describe this calculation is called interval estimator lah. So this is what we call interval estimator. Ataupun sometimes we call it as a confidence interval, right? Sometimes kita dalam banyak buku kita panggil confidence interval. It's the same thing lah, same definition. Confidence interval, interval estimator is the same thing, right? So additional information, let's say we want to estimate the parameter theta. So statistic used to approximate or estimate the parameter theta is called as point estimator, which is mu hat. Ini I ulang banyak kali. So means that this is very important note to remember. And then the value of the theta hat we call as a point estimate. Right? Tadi I ulang sekali lagi. Theta hat is equal to x bar, which is equal to 2.50. So this is what we call as point estimator, and this is what we call as point estimate lah, right? This one sama, benda yang sama lah. So x should have some values. Okay, so I hope you understand the concept of point estimate and point estimator. So let's look at a table of point estimate. So let's say you have a target parameter. So just to be clear, I want you to understand the definition of parameter and statistics. The parameter means that the statistical or numerical summary taken from population. Statistic without S is numerical measure calculated from sample, right? So let's say you want to find the target parameter is mu, right? And then you have a sample size of n, and then point estimator should be x bar lah. This is a sample estimator lah, right? And the standard deviation or standard error should be sigma over square root of n, and the rest are the list of point estimator for proportion and for single mean and two mean, right? Okay, now let's look at example number 1, right? So example number 1, just to emphasize the concept of point estimator and point estimate, right? So suppose college president wish to estimate the average age of the student attending class this semester. The president could select a random sample of 100 students and find the average of this student. Let's say average is 22.3 years. So mu hat is a point estimator. This is also called a point estimator. So terbalik, I think this is a point estimator, not this one, right? And then this is a point estimate. X bar equal to 22.3 is a point estimate, right? Okay. Boleh, So very simple. Let's look at example number 2. So in example number 2, a sample of 35 observation is taken from the population, so we have the data, and we want to calculate the point estimate for mu and variance. So the point estimate for mu should be equal to x bar, which is equal to 1 over n summation of xi, where I equal to 1 until 35. Right. So let's say you calculate the data, you key in the data into a calculator, you will get 1,342 over 35. So this one should be 38.34. So you can say is that mu hat is equal to 38.34. So this is a point estimator and this is a point estimate, right? And point estimate for sigma squared should be equal to s square should be equal to 1 over n minus 1, and then x summation of x square minus summation of x and then u squared, right? So this one should be divided by n, and this one should be, kalau you calculate, you akan dapat 1 over 35 minus 1, and then this one is 51,554 minus 1,342 squared divided by 35, right? And then this one should be equal to 2.88. So we know that sigma square hat, the point estimate for sigma square is equal to 2.88, right? So these first two example is to make sure you understand the concept of point estimate and point estimator, right? So now by right you should know how to differentiate what is a point estimate and what is point estimator, right? So now look into the real topic, right, that we're going to discuss, which is finding the point estimate. So we're going to have two methods. We're going to learn two methods to find a point estimate, right? Basically, there are a lot of methods available, right? Such as method of moment. This is a method that we're going to learn. Another one is maximal likelihood estimator, and the topic that the method that not covered in this subject is Bayesian estimation, method of least square, likelihood ratio. Semua tu kita tak belajar lah. We're going to focus on these two methods only, method of moment and maximum likelihood estimator. So maximum likelihood estimator is a method of estimating the parameter from a statistical model lah. So this is widely used in current statistical techniques, right? So this is basically a frequentist model, right? So this is an old method, which is a method of moment. This is a very old method that we're going to learn, right? But this is very powerful method, right? So now let's look at what is method of moment. So method of moment is proposed near to turn of 20th century by Carl Pearson, right? So this is the father of statistics, Carl Pearson, right? So he developed, he proposed a method of moment, more tractable than a method of maximal likelihood estimator, where the model was multiple, has a multiple parameter lah. Kalau kita ada banyak parameter, and this is more organized compared to maximal likelihood estimator. But it's going to be very complex if you have a complex equation, right? So very simple procedure to find estimator for one or more population parameter lah. Consists of equating the first few moment of the population to the corresponding moment of the sample, right? So since we are talking about moment, things that you need to understand or recall, is about moment about the origin and moment about the mean, right? So let's recall some topik yang kita belajar sebelum ni. You belajar dalam previous subject, moment about the origin, right? If you have first moment about the origin, it should be equal to expected of x, right, which is equal to mu1 prime. So this is the symbol, right, for first moment about the origin, which is also equal to expected of x. Second moment about the origin is equal to expected of x, sorry, this is not x2, x square, which is mu 2 prime, right? So the kth moment about the origin is equal to expected of x power of k, which is equal to mu k prime, right? So I hope you understand the notation here. Another one is we need to understand the second moment about the mean, which is equal to variance of x, which is equal to expected of x square minus expected of x, and then u squared, which is also equal to mu 2 prime minus mu 1 prime squared, right? So just to recall your knowledge, previous knowledge, right? Now let's look at theorem number 1 for method of moment, right? So the k sample moment of the set of observation x1 until xn, right? So is the mean of their k power and is denoted as m k prime, right? Which is we already recall here, right? Symbolically, we want to find the average, right, of k, power of k, right, of power of k divided by n, and then thus if the population have r parameter, so the method consists of solving the system of the equation mu k prime equal to m k prime, which is also equal to, let's say you want to find the first moment about the origin should be equal to x bar or equal to mu lah, right? The second moment about the origin, about the mean should be equal to sigma square, right? And this one should be equal to 1 over n summation of x, right? And this one should be the variance, right? The variance should be 1 over n summation of x square minus x. Sorry, this is not x square. Should be xi minus x bar square. Right, so this is a population variance and this is a population mean, right? Okay, so to solve the equation, to find the what we call as a point estimate, so the theorem says that we need to solve the system equation, right? Solve the system equation. So mu k prime equal to mk prime. Mk prime is the statistic lah, numerical summary of the sample, right? So now let's look at the step in method of moment. Very simple step we have. First step is we need to find a k moment about the origin from this random variable, right, which is equal to mu prime, mu k prime, right? Usually if you have only single variable, a single parameter, so it's only stop at mu 1 prime, If you have let's say 2 parameter, you're going to stop at second moment about the mean, right? So the second step is corresponding kth sample moment is the average. So we need to find the average or the sample statistic for for the corresponding mu 1 prime, right? Which is this is divided by n. Can you adjust this one? 1 over n summation of xi power of k, right? And then we need to equate the corresponding population and sample moment and solve the desired estimator, right? Now let's look at example for understanding this step, right? Example number, so this is a recall, tadi kita dah tengok. Example number 3. So example number 3, given a random sample of size n, right, size n, random sample of size n from a uniform population with beta equal to 1, and use a method of moment to obtain a formula for estimating the parameter alpha. So PDF of uniform distribution is 1 over beta minus alpha, where x is from alpha and beta, right? As said in theorem number 1, first we need to find the moment, the kth sample of moment, right? Or we can look at into the step in of finding method of moment. First is we need to find moment about the origin, right? If you have a single parameter, means that you're going to have only first moment about the origin. Kalau you ada dua parameter, means you need to extend lah, right? You need to find the second moment about the origin and find the second moment about the mean, right? So first step, we need to find the first moment about the origin, which is mu1 prime, which is also equal to expected of x. This one is a numeric continuous random variable, should be from alpha to beta. This is x over beta minus alpha with respect to x. And from a prior knowledge, we know that so kalau kita tak buat pun tak apa, kita boleh integrate this one. So beta minus alpha from alpha to beta. So this one should be beta squared over beta minus alpha squared divided by beta minus alpha. But remember tadi I integrate ni, I lupa nak letak 2 kat bawah kan. So should be 2, right? And then this one should be equal to beta squared minus alpha squared divided by 2 beta minus alpha. So if you expand this equation, right, so it should be, kalau kita factorize kan, this equation should be alpha plus beta beta minus alpha divided by 2 beta minus alpha. So this one should be alpha plus beta divided by 2. So since beta is equal to 1, beta equal to 1, so it should be mu 1 prime should be equal to alpha plus 1 divided by 2, which is also equal to mu, so equal to the average lah. So this is expected is equal to average kan. So next we need to equate to the sample statistic, right, which is x bar, right? So x bar equal to alpha plus 1 divided by 2. So we want to estimate the parameter alpha. So we need to take out alpha ni, letak dekat luar lah. So this one should be 2x bar minus 1 equal to alpha, right? So then alpha hat should be equal to 2x bar minus 1. So this is the estimator or point estimator for alpha. Boleh? Right, okay. Any questions so far? Very simple step. So first step, kita find the first moment about the origin. Second is we need to find the sample statistics and then we equate the equation. Right. So let's look at example number 4. So given a random sample of size n from a gamma distribution, a gamma population, right? So we need to use a method of moment to obtain a formula for estimating the parameter alpha and beta. So now in gamma distribution, we have two parameters, right? Alpha and beta. So the PDF for alpha, as for gamma, is 1 over beta power of alpha, gamma alpha, right? X power of alpha minus 1 exponential negative x over beta, where x is more than 0. And provided alpha also more than 0 and beta also more than 0. Right? So this is the PDF for gamma distribution, right? So we know that from the prior knowledge, right? The expected of x for gamma is alpha and beta, and the variance of gamma distribution is alpha beta squared, right? Alpha beta squared, right? Let's say you don't know, if you don't really know the mean and expected value, you can remember this theorem. So look at the theorem. The R moment about the origin of the gamma distribution is mu r prime, it should be equal to beta r, right? And gamma alpha plus r divided by gamma alpha. So this is a theorem for finding r moment about the origin. But basically we don't need to understand this one, right? Because we already know from a prior knowledge, expected of x is equal to x alpha beta, variance is equal to alpha beta squared, right? So since we have two equation here, two parameter here, right, which is alpha and beta, right? So we have two equation, two parameter. So first step is we need to find the mu1 prime. So this is the first step, which is equal to expected of x, which is equal to alpha beta. So this is the first theoretical moment about the origin. And second step is we need to find the second moment about the origin, about the mean, right? Second moment about mean, which is equal to variance of x, which is equal to alpha beta squared. Right, so this is the first information that we know from the distribution, right? So this is going to be the first step lah, right? Remember, the first step we need to find the first moment about the origin, the second moment about the mean for if you have two parameter. The step number 3, which is second step in our model. So first we need to equate the first moment about the origin with the sample statistics, right, which is equal to expected of x equal to mu 1 prime equal to alpha beta equal to 1 over n summation of x, right, which is also equal to x bar lah, this one, right. Basically we want to equate this one and this one lah, right. Apa yang tulis semua untuk for our understanding. And the second one is step number 4, variance of x equal to mu 2 equal to alpha beta squared, which is also equal to 1 over n summation of xi squared. Sorry, this is a summation of xi. This is a population standard deviation, which is equal to summation of xi minus x bar squared. Now we have first equation and the second equation. So we want to solve for alpha and beta, right? So let's solve for the first one, which is alpha beta equal to summation of x over n, right? So let's solve for alpha equal to this is also equal to x bar. Kita make it short lah, senang this is equal x bar minus divided by beta lah, right? Ataupun nak buat panjang pun okay, it's okay, no problem. So this is unsolvable lagi sebab we have a second parameter dalam in the equation, right? So we want to eliminate the parameter symbol. So let's look at the second one, which is alpha beta squared equal to summation of xi minus x bar squared divided by n. And we know that alpha is equal to x bar divided by beta power of multiply with beta squared, right? So I just replace this one to here, right? So this one should be summation of xi minus x bar squared divided by n. So since we only have one parameter here, so we can solve the equation. So this one should be beta equal to summation of xi minus x bar squared divided by n x bar. So the estimator for beta is equal to summation of xi minus x bar squared divided by n multiplied by x bar. So we just substitute this equation to the first formula, right? So alpha hat should be equal to let's say letak macam ni, this one, summation of xi minus x bar squared divided by n x bar. So this one should be n x bar squared divided by summation of xi minus x bar squared. So alpha hat should be n x bar squared divided by summation of xi minus x bar squared, and beta hat should be summation of xi minus x bar squared divided by n x bar. So this is the estimator for alpha and beta. Right? Boleh? Any questions so far? Can you see the step? Nampak step dia? Senang saja kan? So first we need to find the first moment about the origin, or the second moment about the mean for if you have two parameter, and then find the sample statistic and then solve the equation. So let's look at example number 5. So example number 5, suppose we have y1 equal to 0.42, y2 is equal to 0.1, y3 is equal to 0.1. Then we need to adjust this one, bagi variety sikit. This is 0.65. And y4 is equal to 0.23. It's a random sample size of 4 from a probability density function, theta y power of theta minus 1, where y is in between 0 and 1. So we want to find a method of moment, estimate for theta. First step is we need to find the first moment about the origin. So let's look at the fy here. We only have theta y power of theta minus 1. So from 0 to 1. So we only have one parameter here. So since only you have one parameter, so we only compute for first moment about the origin. So this one should be expected of y equal to y power of multiply with theta y theta minus 1 with respect to y. Right? So this one should be 0 to 1 theta y theta with respect to y. So if you integrate, this one should be theta y theta plus 1 divided by theta plus 1 from 0 to 1. Right? So this one should be equal to theta divided by theta plus 1. So this is the first moment about the origin. So we know that second step is expected of y equal to 1 over n summation of yi, which is equal to y bar, right? Which is, we're going to, step number 3, we're going to equate first moment about the origin and y bar. Right, so this one should be y bar equal to theta over theta plus 1. So y bar theta plus 1 equal to theta, right? So this one should be y bar theta plus y bar equal to theta, and y bar equal to theta minus y bar theta, and this one theta 1 minus y bar. So this one should be y bar over 1 minus y bar equal to theta. So we can say that the estimator for theta is equal to y bar divided by 1 minus y bar. Right? So since we already know the estimator for theta, then we want to find a point estimate for theta. So y1 equal to 0.42, y2 equal to 0.10, y3 equal to 0.65, and y4 equal to 0.23. So y bar should be equal to 0.42 plus 0.10 divided by 4. So this one should be equal to 0.35. So theta hat should be equal to 0.35 divided by 1 minus 0.35. So this one should be equal to 0.54. So this is the point estimate, and this is a point estimator for theta. Alright, so let's move to example number 6. Yeah. So example number 6, um, tengok sekejap lagi 3 example je lah, tak banyak ah. So example number 6, a random sample of size n drawn from exponential population with a parameter theta, right? So estimate theta using method of moment. So first thing we need to know the PDF for exponential. So PDF for exponential is 1 over theta y. Sorry, this is exponential negative y over theta. Exponential negative y over theta. For x is more than 0. So first step, very simple. Since we only have one parameter here, I think sama ke atas? Tak sama. Right. So first step, very simple. We need to find the expected of y, expected of x. This is x, which is first one is mu1 prime, right? Mu1 prime is equal to expected of x. So we need to integrate this one from 0 to 1. So x multiply with 1 over theta exponential negative x over theta with respect to x. So when we integrate this one, you should get theta lah, right? So because the expected of x for exponential is equal to theta. Second step is we need to equate the equation with the sample statistics mu1 prime equal to x bar, right, which is also equal to x bar summation of x divided by n. So this one very simple, x bar theta hat equal to x bar, right? Very simple, tak ada macam nak kena olah ha. Let's look at the second last example, right? Example number 7. Example number 7, very simple. So let x1 until xn be a random sample of size n from a distribution with a probability distribution function of this is x power of 3, 6 lambda power of 4 exponential negative x over lambda, where lambda is more than 0. So we want to find the estimator of lambda for the parameter lambda using method of moment. So let's look at the PDF. We only have a single parameter, only one parameter, which is equal to lambda, right? So first step, we need to find the mu1 prime, which is the expected of x, right? So since this is continuous random variable, so we need to integrate from 0 to, so basically this is not basically x is more than 0 lah, lambda is also more than 0. This is until infinity, right? So x power of 4 divided by 6 lambda power of 4 exponential negative x over lambda with respect to x. So when you do integration, you need to do integration by part because we have two variable here, a separate variable x power of 4 and exponential negative x. So when you do the integration by part, you should get 4 lambda, right? So the second step is very simple. We need to equate with the sample statistics. So mu1 prime is equal to x bar, and this one should be 4 lambda equal to x bar, and then we can say that lambda hat equal to x bar divided by 4. Very simple. So only 3 steps, right? But the step for step number one ni agak panjang sikit lah. You need to find the expected of x. Right, you need to solve the equation. Now let's look at the last example for method of moment, and then next kita akan masuk maximal likelihood estimator. So for example number 8, right? So let x1 until xn be a normal random variable with mean equal to mu and variance equal to sigma squared. What are the method of moment estimator for mean and variance? So we know that from prior knowledge, expected of x is equal to mu and variance of x is equal to sigma squared. Right? So this is for normal random variable. Right? Normal random variable. This is based on prior knowledge. And the second step, we need to equate. This is mu1 prime and this is mu2. Right? So we equate mu1 prime equal to x bar. So this one should mu hat equal to x bar. The second one is this is also equal to 1 over n summation of xi lah. Yang sama lah, very simple. Mu2 equal to sigma squared kan. Sigma squared is equal to 1 over n summation of xi minus x bar squared. So we can say that sigma squared is equal to 1 over n summation of xi minus x bar squared. So we know the estimator for mu and variance. That's all. Very simple. Right? So method of moment very straightforward. First we need to find the first moment about the origin and equate with the sample statistics. Right? And solve the equation. If you have two parameters, find the second moment about the mean and equate to the sample statistic and solve the equation. Very simple method. So next class we will look into maximum likelihood estimator, which is a bit this is a very general method for estimation and widely used for many statistical model, right? So I think that's all. Ada soalan tak before we end our session? Alright, if you don't have question, then I think that's all. Thank you very much. Assalamualaikum.